Welcome to a new test and teardown video. This time it's another radiometer. This one is called a standard signal generator type MS 111B. It covers many frequency ranges all the way from 10 to 110 megahertz, and it can do modulation and external modulation, internal, all that kind of stuff. We got different outputs depending on signal level, and so we got all the different outputs here. And this one is a little bit modified. See, here's a special kind of plug for mains entry, and this model exists in many different revisions from 2 to 6, and if you look at the schematics, you can find them at peel.dk. You'll see the date of the schematics is between 1959 and 1962. So yes, this thing is more than 60 years old. That is impressive. I bought it at an auction, I don't know, half a year ago or something like that, and I just had it on stock. I was told a few of the ranges, they're a little bit unstable, but I think that is all in this carousel switch. There's a very, very big, long knob here on this, and you need to use many, many kilos. And here's actually real funny if you look at the indicator here, see? So it's now between 21 and 46, for example, so it's pointing between, you see what I mean? So that means, if we go again here, let me just show you this, 21 to 46. See the fun thing? We got 3 different indicator points on the scale. Let me see if I can show you the numbers on the scale. So if I crank this all the way to the right like this, then this scale is 45, right? A little bit over 45 is probably 46. See what I'm saying? So it's that scale. So this is how you figure this out if you're in this scale. So I guess this one, if you go all the way down, see, 21. So that matches this range. But what if I am in this range, 21 to 10? Okay. So that it can't be that range, right? Oh, what? Oh, 22. So a little bit under 22 is that range, right? And then I can go all the way to 10. So depending on the different ranges, you need to use this, or that. That's a little bit cool. And of course you got this fine adjustment. It's actually the same oscillator output that goes directly to all the different outputs. It's just different multipliers and attenuators and all that kind of stuff that is connected to them, so you can have many different ranges of signals. So, and you can select the meter here if you want this to be modulation or carrier. So that is the thing. But I think we need to open this before I power it up. I think it is very, very wise to inspect such old equipment before you just power it up. It's probably going to avoid all sorts of bad things. So look at this carousel switch. I don't know if you can see, there's a little switch here that goes to a red, yellow, green wire. If we follow those wires, you see they go to 3 different lamps. Isn't that cool? So the lamps, they're mounted right behind the 3 different indicators. So that little tiny hole here is probably going to be lit depending on the different range. Haha, that is nice. And of course this design is a box inside a box. That is a good way to make something really good shielded. We got a little bit of handwriting here. I can see some tube sockets and stuff. But so far I don't see any real bad corrosion, all sorts of damages. I see a little bit on the socket down there, and I don't know. Oh, Houston, we got a problem. You need to inspect good old stuff like this before you power it up. Both those capacitors, they're completely leaked. So nothing is going to work. And the worst scenario will be there's like a short or some other kind of stuff here, and it's gonna blow up the rectifier and whatnot. So yes, I need to service that. Also got a power resistor here that looks a little bit to the dark side. So that is something I want to inspect. And other than that, let me see if we got... Oh, come on, man. Why don't you just... Voltage regulator tube. Here is some PL81. Ooh, high voltage goody stuff. That looks a little bit weird here on the top. And then some isolation. And that is the... What is the gear? It's actually amazing how well they work. This springy coupling and all equipment, more or less this age, it was all done like this. They stole this idea from each other, and it's a complete copy. All of them, they're doing this. That is funny, isn't it? Oh, we got even a connector here. I think I need to go in here and have a look. So I'm still in the progress, I guess, about unscrewing all the screws here to go inside this cabinet. But then I'm looking a little bit at this power potentiometer here. That is the carrier level. But look at that meter here, or this resistor here is really dark, and it's, can you see, compared to the other one, this is how it's supposed to look, but it's completely burned. So I mean, that drive level here has something to do with all sorts of stuff. This can't be good. I don't think I will be able to repair that if it is broken, but I will do a little ohm check. Look at this. This is inside the case. So those capacitors really puked all over the case. Oh my goodness. And now I understand why this power potentiometer is so dark and brown and burned. And that is, of course, if you see the, I don't know if you can see the colors here, but there's also a red one. And that is because this is voltage from the capacitors and from this is the power inductor. I believe that is the filter component. See, here is the high voltage from the rectifier, goes to 1, and then very large inductor, and then the other capacitor, and then back to the drive voltage for, I believe the output tube is probably that one, right? And yes, so that explains why this potentiometer is so burned, because we got broken capacitors, right? And the voltage is probably over that, and oh no. Oh yeah, see, here is a, I think, what is that doing? Let me have a look. Oh yeah, this is output attenuator and power resistors, and they cooled it down, so putting the resistors inside this metal, that is quite nice. Maybe it has something to do with coupling between the different components, right? That one is probably okay. So here's the carousel switch for all the different bands. Very neatly made. I can't find the, yes, here it is. Down here is that will be the contacts for all those contact points, and then it goes to this capacitor for tuning. And where is the, is it here? Is that the oscillator tube together with this? Maybe it is. Oh, this is really nice and soft, this coax. Yeah, I think I will try and change those two capacitors, and then I'll try and see if I can boot it up and what is going on here. Definitely think I found one very important problem. Holy moly, those two capacitors completely puked. But they're super easy to remove, so... And look what I said about this filter choke. 10 Henry, 70 milliamps. So that's definitely how you make a good anode supply. Now I'll go and see what I can find. Oh, what about that one? Is that a little bit leaky here? Yeah, we'll see. So I got both the schematics from peel.dk, and I tried to compare the two versions he got, version 2 and version 6. And it turns out this one is version 2, because of the carrier potmeter is 2 different potmeters that's connected together mechanically. One is 5K and one is 10K. And this is actually the high voltage divider for a regulated 160 volts, and then this goes to the first oscillator tube, the output voltage. So this is a very, very funny voltage divider potmeter made from 2 potmeters, as you can see here. One end of the resistors is just connected together. Let me remove this. And then the center point of the 10K is connected to ground. And that center point is, what is that? That is the output. That is the voltage for the amplifier, and here is the 160 volts. So the fun thing is, by doing it this way, as you can see, what happens, right? Now the output is connected directly to ground, and there is highest resistance to ground from input voltage. So what if we go to maximum output? Here is my input voltage, and it goes all the way out. And see, there's now highest resistance to ground from that point, and then there's all this resistance to that point, and then all this resistance to that point. So then again, there's no power loss in the pot meter. So why is this one so brown and burned? That is really weird. Or is it just painted in a different color because it is different resistance, so it is not exactly the same pot meter. What I also wanted to show you, and that is why I kind of clicked on my ohm meter here, that was to show you how bad, how annoying. I wanted to show you. Here we go. Oh, that's impossible to show today. Nothing will work. It's actually a little bit better now. So that pot meter here seems to be okay. Alright. So let's take the other one. See that? Now I'm measuring this one, right? And then nothing happens. How the heck is that possible? Yeah, okay. So that one's just open all the time, and then sometimes it's a little bit. This is just completely useless. So I need to massage this a million times, and then I guess I could just get whatever carrier level that is and then just live with that, because I'm definitely not going to get anything useful out of this. Completely crap. Well, I still feel I need to go and change those capacitors then, and then see if I can boot it up. Let's look a little bit at the carousel switch. This is how they're normally made, with a flexible end. It's really difficult to get some light in here. So this end here of the wheel is flexible. See if I push this a little bit, and that is how they're put in all the different frequency settings. So you push this and then stick it in, and this is how I got one of them out, just to show you. So there's a level and the capacitor and the inductor. I've got some other capacitors, resistors and stuff right here. That is essential for this frequency range. And this is just called number 9. There was a sticker on this unit that said something about some of the ranges. They were a little bit unstable. And that is why I took this one out, because I wanted to clean the contacts and inspect how the different pins here they are mounted, because if they're loose or something like that, I wanted to figure out how can I fix this and how can I make them more stable and all that. So now I'll try and assemble this again. Probably not that easy as it was to take it out, huh? But it's quite beautiful. There's a lot of hand work to do here. This entire unit is one big hand job, right? Because look at all this hand soldering, hand doing this, and hand, everything is done by hand. A lot of work. Oh yeah, I also saw another, let me see if I can get some light in here. I don't know if I can get that in focus, but in here there's actually another switch, probably some compensation and level and all that kind of stuff for the different frequency settings. And I also found some other really cool thing in this unit. I wanted to show you. Look at that transformer here. It is actually an open core. It's made so it's very easy to unscrew the two ends. You can see here, right? And then you can play with the windings. I mean, it's like a build-it-yourself transformer. Isn't that cute? Now I'm playing a little bit with this mains cable. Funny solder directly to the pins. Tie a knot, and then a little plastic thing here with a hole, and then the screws here. It's actually not such a dumb way to do it. And the only thing is that we don't have any earth connection, and I need that for safety, life protection, definitely. So I cleaned it up a little bit, fixed all that, removed all the old solderings, and made this original again. And here we go with a proper connector, and that is, of course, as you can see here, this is the chassis metal, and of course you got a connector that is connected to chassis metal, and of course you want a connector with the ground for your own protection. I am not super proud of this solution, so please forgive me. But okay, I got some capacitors in, alright? And it's easy to see what I've done here, and this is really easy to fix when I get the correct capacitors. But so far, I think we are safe to proceed to the next level, and that is my first power on. So let's do the first power on, and in case anything bad happens, we got it on video, right? Mains is applied, nothing bad happened, we got light. 60 watts, 50, 40, that is absolutely what I expected. Let's see if we get some output. 38, and then it goes up again, and this is completely normal because of the tubes. 60 watts, we got output. 65 watts, oh my god. And that is 1.2 megahertz. Let's see. That is nice. How is this? I would expect that to be, that is why. Attenuator, and then okay, then it's super weak, microvolts and stuff. All right, that is why. Duh, 2 volts, and then this attenuator is not working, right? Looks like it is a little bit working. Wow, it is a live. And what have we got here? I am now in 1 to 2.1 megahertz. Let me go a little bit closer. How cool is that? Let's turn off the light. So there's clearly light in this one. I'm so sorry because I got some light shining from the window that's also reflecting on the others. If I do like this, you could probably easier see. This one is lit. So that means if I crank the frequency here, 1, 2, so between 1 and 2.1, that will be 1.2 megahertz, I would assume, right? So let's see if I can do it as accurate as I can. See, there's a tiny little line here, and then oops, here. Let's go make this one 0. I don't know if you can see this. Now this one is 0, so oops, this don't line up. Why is this not lining up when this is 0? So what if I put this for 1.2? So this is the one. Okay, so this is just some useless scale that is not important, because look at that, 1.2, and then we go to the oscilloscope. That is 1.2, very close to 1.2. So this 60 years old thing is actually still accurate. at least in this range. I mean, let's try the different ranges and see what happens with the lamps. Are they working or not? Yeah. And then, oh, this is so cool. I love it. Okay, so the lamps works. Yes, this is the highest range, and that is exactly what they said where I got it. They didn't say anything about the exploded capacitors. See if I crank a little bit here on the carousel switch. That's actually quite alright now. Let me go a little bit faster. So this is from 46 to 110. And now it is so easy when I got the light. So okay, so let's go for 100. So that should be around 100, right? And what have we got? Oh, that is very close to 100. I read 99.36. Oh, lovely. So the guys at Radiometer, they don't screw around, I'm saying. I am a little bit impressed. It is this accurate. And okay, this range works. So now I'll play a little bit with the different ranges and I will see if I can find anything wrong. But so far, let me see if I can show you both the output and the range. So here we go, right? Let's try the different ranges. And let's... You need to use 1,000,000 tons to handle it. Oy, 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 oy. So here goes kilocycles. I think this is the lowest, 10 to 22 kilocycles. Ooh, that is not looking super beautiful. Has it something to do with carrier? See, that was the pot meter. Okay. There's nothing here that's... Aha, modulation is working as well. Well, okay. That is the lowest range, and then it looks a little bit weird. Ah, next one is far better. Ah, and then it goes a little bit better. I totally love it. It's of course a little bit big and a little bit heavy, but it's definitely got something. Especially this with the light. And then it goes. Oh, look at that one. Every time I change the... So this is the power. Look at the blink on the... Why is it doing that? That is fantastic. And just to show you, the modulation of course also works. This is a nice internal modulation mode, and we got of course variable modulation here, and this is AM, and it just really works. You can go all the way to 100%. Oy, oy, oy. All right, I think that is more or less what I wanted to play with so far. I figured out why this carousel switch is so hard to move or to turn around here, and that's because see, there's a little wheel and I don't know, a this should be kind of a bearing, you know what I mean? There's a shaft that moves in here, but the pressure here is very, very hard. So what I did is I added a tiny little drop of oil on both sides so that it will make this wheel here spin a lot easier. And there's actually also a tiny little drop of oil here on this wheel here, right? So what happens now is when I turn around the switch, there is a much better feeling. Okay, it's still a little bit tough, but at least it's not feeling like you're breaking something anymore. So that was a big help. Tiny little drop of oil and then that is solved. So I don't want to say a lot more about this unit. Thank you very much for watching. See you again tomorrow. Bye bye.